Have you ever looked up at the night sky and felt a sense of profound stability? The stars, the galaxies, the very laws of physics that govern them all seem so constant, so reliable. But what if I told you that this stability, this permanence we take for granted, might be a complete illusion? What if our universe is living on borrowed time, perched precariously on the edge of a cosmic cliff? There is a theory in physics, a chilling possibility known as false vacuum decay, that suggests just that. It proposes that our entire universe exists in a state that isn't truly stable. Think of it like a ball resting in a small dip on the side of a much larger, steeper hill. The ball is stable for now, sitting comfortably in its little hollow. It won't roll away on its own. But that little dip isn't the lowest point it could be. There's a much deeper valley, a state of true stability, just a short distance away. All it would take is a small nudge, a random jolt of energy, for the ball to be pushed over the edge. Once it's pushed, it will roll down into the deeper valley, releasing a huge amount of energy as it goes. It will find its new, truly stable home at the bottom, and it will never be able to get back up to the little dip it was in before. This is the core idea behind false vacuum decay. Our universe, according to this theory, is like that ball in the small dip. It's in what physicists call a false vacuum state. It's a state of energy that is stable, but not the lowest possible energy state. There exists another more fundamental state, a true vacuum, with a much lower energy level. If a tiny region of our universe, even a quantum-sized speck, were to somehow tunnel through the energy barrier and drop into this true vacuum state, the consequences would be catastrophic. This event would create a bubble. It's a bubble of the true vacuum. This wouldn't be a bubble of empty space as we know it. It would be a bubble of new reality, with fundamentally different laws of physics. The constants that govern our existence, like the mass of an electron or the strength of gravity, could be completely different inside this bubble. Once formed, this bubble would begin to expand outwards in all directions. And here's the truly terrifying part. It would expand at the speed of light. Because it moves at the absolute cosmic speed limit, nothing could outrun it. No information, no warning signal, could ever precede its arrival. From our perspective, it would be the ultimate sudden end. One moment, you're looking at the stars, and the next, you simply wouldn't be. You, the Earth, the Sun, our entire galaxy, and everything we have ever known would be instantly deleted from existence as the bubble's wall washes over us. It wouldn't be an explosion in the conventional sense. It would be a total and complete rewriting of reality itself. The very fabric of space and time would be reconfigured into a new, more stable form. The atoms that make up your body, the planets, and the stars would be torn apart and reassembled. Or perhaps annihilated entirely, according to the new physics of the true vacuum. What would it look like from the inside of the bubble? You can only speculate. Perhaps the new physics would be sterile, unable to support any form of complexity, let alone life. It could be a universe where atoms can't form, where stars can't ignite, a place of featureless, low energy, emptiness. The transition wouldn't be painful or frightening. It would simply be over before our brains could even register that it had begun. It is the ultimate cosmic blindside. There is no defense, no escape, and no warning. The bubble of true vacuum would simply arrive and overwrite everything. You might be thinking this all sounds like science fiction, and in a way it is. It's a theoretical concept that emerges from our understanding of quantum field theory and the Higgs field. The Higgs field is what gives fundamental particles their mass. The current value of the Higgs field is what allows for the specific physics of our universe, the kind that lets stars shine and planets form. The theory of false vacuum decay suggests that the current value of the Higgs field corresponds to a false vacuum. A different lower energy value would correspond to the true vacuum. Scientists have even tried to calculate how stable our universe's vacuum is based on the measured mass of the Higgs boson and another particle called the top quark. Results are unsettling. The calculations suggest that our universe is metastable. This means it's not truly stable in the long run. But its lifespan is so incredibly long that it's practically stable from our perspective. The estimated time it would take for a spontaneous quantum fluctuation to trigger a vacuum decay event is mind-bogglingly vast. Trillions upon trillions of years, far longer than the current age of the universe. So, you can probably sleep soundly tonight. The chance of it happening randomly, right here, right now, is infinitesimally small. The universe is likely to end from heat death long before a random bubble of true vacuum appears. However, there is another possibility. What if the event isn't random? What if something could give the universe that nudge needed to push it over the edge? Could a high-energy event like a particle collision in a super-advanced accelerator, or a natural cosmic cataclysm of unimaginable power, concentrate enough energy in one place to trigger the decay? The physics is so extreme that it's beyond our current technological capabilities, but it raises a profound question about the limits of scientific exploration. This theory forces us to confront the fragility of our existence on a scale we can barely comprehend. It suggests that the cosmos is not the solid, dependable stage we imagine, but a delicate, temporary arrangement. Everything we see, everything we know, every law we've discovered might just be a local bylaw. A temporary condition in a specific corner of the cosmos that is destined to be overwritten. The universe we inhabit could be just one phase in a much larger, more violent cosmic story, a fleeting moment of complexity before a final, its permanent state of simplicity. It's a humbling and somewhat terrifying thought, a cosmic memento mori that reminds us of the profound mysteries that still lie at the heart of reality. The stability we experience is a precious and perhaps temporary gift. Did this cosmic doomsday scenario get you thinking? If you want to explore more mind-bending theories about our universe and our place in it, be sure to subscribe to Space Repo.